Hello, my name is Mathis Rieke. As a representative of the OWS-9 Aviation Data Provision team, I will present the work carried out within this testbed. The data provision services are the foundation for the aviation architecture. The web features services act as data stores for AIXM 5.1 features. Event service instances provide publish-subscribe functionality on top of these data. During OWS-9, several new features focusing on enhancing and improving the service interfaces have been developed. In general, these features can be summarized as the advanced filtering functionality. In particular, 6 individual new features have been developed: stored queries and filters, AIXM features as geometry operands, spatial filtering of non-spatial features, simple altitude queries, event service update intervals, and selective metadata retrieval. But first of all, let's take a look at the service architecture and its common workflows. Clients and intermediary components like the data management service can retrieve AIXM features from the WFS instances. Also, they can subscribe at the event services for a subset of update events on these features. Whenever an update to a feature has been populated to a WFS, a digital NOTAM is created and pushed to the event services. If necessary, the event services can pull additional data from the WFSs. Those digital NOTAMs which match a subscription are then forwarded to the client. A handy feature of the WFS 2.0 specification, the stored queries have been used for the first time within an OWS aviation thread. Stored queries allow server administrators to predefine commonly used complex queries so that clients can easily reuse them. They can be defined for the get feature and the get property value operations. There are several interface methods to manage the stored queries of a WFS instance. Let us take a closer look at the creation of a stored query by using the createStoredQuery method. Such a request contains a stored query definition. It defines an unlimited number of parameters which are referenced in the query expression part of the request. Here we can see a query returning airport-heliport features which AIXM name attributes match the parameter name. An EPIB client makes use of the stored query to populate the drop-down list as shown here. Each time a name is typed, the stored query is run and the drop-down list is populated with a result. In this example, the previous getPropertyValue query is used to retrieve the value of the AIXM name attribute. By analogy to WFS stored queries, stored filters have been developed for event service subscriptions. Another feature which has been developed for event service subscriptions are update intervals. They provide a way to define a time window for which matching events are collected and forwarded after the specified time as a batched message. The following demonstration illustrates both the update intervals and the stored filters feature. The starting point are 2 event service subscriptions, one with a smaller buffer around a flight route and a second with a wider buffer using update intervals. Here we see the update interval specifics of the subscription. Let us define a time window of 15 seconds. At the end of each time window, either a message with the latest notification or a system message stating that no update has been received within this interval is sent out, as you can see in this example. In this simulation, we are now receiving a notification which matches the smaller buffer. As this subscription does not use update intervals, it is not received at the end of the time window. The notification informs about the limited operational status of the Chicago destination airport. Meanwhile, in this simulation, another DNOTAM matching the wider buffer has been pushed to the event service. This message is disseminated at the end of the 15 seconds time period. It informs about the limited status of an alternative destination airport in Milwaukee. In a real-world scenario, such update interval functionality can support the pilot to focus on the most relevant information, here updates on the destination airports. In the background of the simulation, another DNOTAM for the Milwaukee airport is sent to the event service. It is again disseminated at the end of the time window. 2 dissemination methods have been developed for update intervals: a batching mechanism to combine all received notifications in one, and a mechanism to only provide the latest notification. Another new feature provides the capabilities to do spatial filtering using AIXM features which do not define a geometry on their own. Here the spatial extent is resolved using associated features such as taxiway elements and associated taxiways. Using a common event service subscription with a spatial filter, the non-spatial feature workflow is triggered on reception of a notification which contains a non-spatial feature like a taxiway. In order to determine the spatial extent of the taxiway, a web processing service implementing the geometry retrieval profile is leveraged. The WPS process is executed using the GML identifier of the feature as an input. The result provides the geometry of the associated taxiway elements back to the event service. Internally, the WPS makes use of a custom WFS XPath function, the value of function, to retrieve the associated features of the taxiway. The event service will extract the spatial information from the successful WPS request. The support for non-spatial feature filtering was implemented by WFS instances through the AIXM extend-of XPath function in a getFeature query. Also, work on the general support for AIXM features as geometry operands has been carried out. The goal was to allow AIXM features as one input of FES filter expressions. For instance, it can be used to define a filter for features or events within a buffer around an airport-heliport. An extension XML schema has been developed to allow the provision of features by reference. This has the benefit that clients do not need to inline the complete feature, thus reducing the used network bandwidth. The workflow of this feature is similar to the previously described. A WPS is leveraged to calculate the geometry. For some use cases, metadata has no relevance. As metadata in GML can be quite verbose and big in size compared to the data actually used, a functionality was needed to remove metadata from the response before it was transmitted. This helps saving bandwidth and processing time. The general requirement derived from that was how to remove unwanted parts of the data on request. It turned out that a solution of this problem was already there. The property exclusion projection clause introduced in the WFS temporality extension is designed exactly for that. The property exclusion projection clause allows the client to specify a property it does not want to see in the response. It takes a simple XPath expression pointing to the property to exclude. Here all time-slice metadata properties are removed. To exclude multiple properties, multiple projection clauses can be used. Previous versions of aviation data provision services only provided spatial filtering with two-dimensional geometries. Within OWS-9, an approach has been designed to enable simple altitude filtering. It has been realized within a WFS instance using the example of airspace retrieval by a route segment. The event service implementations leverage the WFS functionality. With a simple trick, the feature of a received digital NOTAM is checked for an altitude match. A WFS request using the same route segment as the spatial filter operator is defined. In addition to the spatial filter, a property filter using the GML identifier of the received AIXM feature is defined. Thus, the WFS performed the check if the feature with this GML identifier is contained in the set of features matching the altitude query. If the event service receives a non-empty result, the simple altitude query evaluates true and the digital NOTAM will be disseminated to the consumer. Within OWS-9, various new filtering features have been developed. The main benefits are simplification of the service interfaces for clients, for example using stored queries and AIXM features as geometry operands, reducing the used bandwidth, for instance through selective metadata retrieval, the capability to filter using feature altitude limits. Additionally, the overall service architecture has been refined and extended. Event services are now more closely coupled to WFSs, and the web processing service has been introduced as a new service for complex geometry operations. Finally, I would like to thank you for your interest in the data provision work. Additional details are provided in the OWS-9 Aviation Architecture Engineering report.